Hello everyone, welcome back to our subject Modern Operating System and Computer Network. Myself Dr. Madhivanandurai, currently working as an assistant professor to the Department of School of Computer Science and Artificial Intelligence in SR University at Warangal. So today we will discuss about this elementary data link protocols and simplex protocols. So what is meant by elementary data link protocols? So elementary data link protocols are most basic and fundamental communication rules for data link layer, which helps to use data management and flow control and error control between the directly connected to the nodes. So while sending the data one to another from user to receiver, we will maintain the data as well as the flow control and error control between the two nodes or sender to receiver. Coming to the today discussion, we will look on this induction like what is a data link layer and what are the elements data link protocols, what are the elementary data link protocols, and in that particular simplex protocols there is a three category. One is a unidirectional simplex protocols and stop and wait noiseless protocols, and third protocol is noisy channel protocols or noisy channel concepts. Then frame structures and error handling methods, then efficiency and performance analysis. And finally, we will discuss about this real world relevance and summary of this today discussion. So as we know, the role of elementary data link protocols are most basic and fundamental communication rules for the data link layer, which helps to manage the data flow and error control between the directly connected nodes. So, what is the major purpose or major role in of elementary protocols? Like it's a framing. So, data should be framed. For example, if I have the data at big size, the data should be splitted as a multi bits to send it to one to another. While framing the data, we can send the data at fast manner with effectively. So here, like as we said, so they divide the raw data in manageable way of unit called frames. So what are the data which I have? We need to frame the data as a manageable way to send one to another, and work flow control. So it ensures that sender does not send data faster than the receiver can process it, which means if I am the sender, I will send the files continuously, while the time of receiver, it may be not read the entire file. So when I continuously send the file, it make it also trouble, which means he should not read or receive the file to take the read the file. So that's why we are saying like sender does not send the data faster than the receiver can process it. And error control. So they manage potential issues like lost or damaged frames to ensure reliable data delivery. Then finally, access control. So which controls the host may use the shared channel at any time, which means like who want to share the file to one to another, we will control for only that persons to access the file at any time. So here we will discuss about this classification of elementary data link protocols. So, here there is a three categories. So one is unrestricted or unidirectional, we can say. So The, so what first we need to understand the role of each protocols. So each protocols added one more real world constraints building towards a reliable communications. So the first protocols we will call as a unrestricted simplex protocols, which means one way data flow only. So for example, I am the sender. I will send the file to receiver side without any acknowledgement or without any feedback from the receiver side. Continuously, I am sending the file one to another. So we will call it as a unidirectional simplex protocols. So in the real world, it's ideal or real world, no error or no flow issues. Only we will use the this kind of protocols. So which means no error assumed in the time, infinity receive buffer, infinity receiver buffer, and purely theoretical. So coming to the stop and wait or stop and wait protocols. So which will called as a flow controlled added. We will add it as a flow control method. Like from sender send to one frame and wait to get the feedback from the receiver side, then send to the next file or next frame to the receiver side. So receiver sends acknowledgement, then ready to for the next process. It prevents the buffer overflow because while connection between this or interaction between this sender to receiver side, we will avoid the buffering of overflow of data, and still no error handling. The next protocol is stop and wait with noisy channel. So here fully error plus flow control also possible. So it handles a lost or corrupted frames, and timer plus retransmission logic also applicable, and single bit sequence numbers can be operated, and fundamentals of ARQ as well also. So here we will discuss in depthly for the each protocols as a simplex protocols. The first one is first protocol is unrestricted or one-way protocols also we can say. So unrestricted simplex protocols. So this is one of the one-way method of data transmission. So coming to the characteristics, the most basic protocol is assume an error-free communication channel and infinity buffer space. The function for these unrestricted protocols like data is sent in one direction only with no error or flow control mechanism. Wherever we will not use a flow control or error handling error no error environment, we will use for these protocols. So the receiver is assumed to be ready to process data immediately, and sender can send the data at any time. So the use cases like simulated ideal and error-free environment, and always ready for the communication channels. So wherever the communication channel is ready for the always, we will use for these protocols, and error-free environment, simulated ideals as well. So here, for example, sender called maybe A, and receiver side called B. So from the sender side, based on the request of receiver side, the file should be or frame should be shared from sender to receiver without any acknowledgement. It continuously shared the frame at one by one. So here, for example, from the sender network layer, he sent the file via network layer from through the physical channel or wireless channels as well. So it will reach the receiver side without any acknowledgement. He can continuously uh, transferring the data or transferring the frames at bytewise. When come to the protocols two, simplex stop and wait protocols. So here we directly understand stop and wait protocols, which means a simplest protocols designed for error-free channels that prevent the sender from overwhelming the receivers. For in case of uh, from the sender, he is sending the data from sender to the receiver. At from once the receiver side receives the frames, then receiver will give the feedback or acknowledgement to the sender side. If the data should be reliable or correct data, the data should be accepted. Otherwise, from that receiver side, ask to send the from sender side, resend the data again to get a correct file or correct format or correct frame. So why we go for this simplex stop and wait protocols? To overcome the protocols of one. So as we know, one without any feedback or acknowledgement, data should be continuously flow from sender to receiver. So here I mentioned sender faster than the receiver frames will up buffer flow or data losses maybe appear. So to overcome these issues, we will use for this stop and wait protocols. Coming to the function, the sender transmit a single frame and then wait for the acknowledgement for the receiver from the receiver before sending the next frame. So once he send the file frame to receiver, he should be wait to get the acknowledgement from the receiver. Then it will be ready for the next frame to share to the receiver side. So use cases. It used like when the channel is reliable but receiver needed time to process the data. So which means that the receiver need to take a time to revise the to process the data and prevent the sending from floating the receivers. So the next protocols like simplex for noisy channel. So here the real physical channels corrupt or lost frames in the protocol 2 has no way to detect or require reaction. To overcome this issue, we will use for this simplex for noisy channel protocols. So the coming to the characteristics like an elementary protocols that address the channels to real world or error prone communication channels. For example, here as a sender side, he send the files frames to the receiver side. Then he will get the feedback from receiver to sender. Further, he ready for this. Come share the next frame. While sharing the next frame, the data should be losses or not a proper receive file from the receiver, say from the sender side. That time we will use for this simplex for a noisy channel. So here the function is it includes the mechanism to detect and handle the errors like lost or damaged frames and to prevent the data losses or damage during the transmissions. While transmitting the data, any losses may be appear or any damage the frames. So due to this, To avoid or to prevent the data losses during the transmission, we will use these noisy channel protocols. So coming to the use cases employed when the communication link is unreliable. Wherever the environment, the communication is not a reliable environment, we will use this kind of protocols. Why we need to prone the errors or prevent the error, recurring error detection and correction as well. So in that simplex protocol noisy channels, so it handling transmission error that real world like error detection. So in the last lecture, we will discuss this some error detection techniques like simplex method, multi method, and checksum method, and cycle renderers check methods. So that four error detection techniques used to use uh, analyze the data while transferring the one to another at reliable data transferred. So here like checksum method and cycle renderers check appended to each frames the like receivers verify on arrival and corrupted frames are discarded. Then acknowledgement like receivers send a positive acknowledgement for each correct frames, tells the sender it is safe to process. Then time or timeout in case of transferring the data, so uh, sender to receiver to the frame. In case of time taken to receive the file, that also one of the reason we should make a prevention of data losses. So like here, the sender start to send a send the start the timer after each frames. If no acknowledgement are arrived from before timeout, retransmit the frames. So for the transferring data has some time to take a reach one to another. In case of not getting the any acknowledgement in particular time, we need to resend the frames. Coming to the sequence number, so the bits are 1 or 0. Sequence number prevents that receiver accepting a retransmit duplicate frames. So coming to the key insight, like this essentially the PR or ARQ protocols, the foundation of all reliable data communications. So here frame structure and fields. So coming to the frame structures like a flag. Flag is nothing but we will start a starting point. So as a sender, a beginning, or we can say like beginning the frames with the special bit patterns. So in the starting point, special bit of patterns which should be appear like that. This tells the receiver that a new frame is starting. Then DEST, which means destination address. So here contains the address of receiving device. It helps to frames reach the correct system. Then SRC address, which means source address. Coming to the source address, containing the sender's addresses, the receiver knows where the frame came from. Then sequence number used in stop and wait ARQ protocol. So only one frame is sent at a time. Sequence numbers are usually like 0 or 1 why one bit only needed to identify current frame, retransmission frame. So in the data payload, in the data payload contains the actual message data comes from the network layer. And this is the end section like methods to detecting the error, like using a checksum method or cycle redundancy check methods for detecting the error purpose. Process like senders calculate the checksum methods. In the last lecture we was discussed about this error reduction method. We need to adding a renderance bit to sender to receiver side to calculate whether the data is reliable or non-reliable. If it is reliable, then we can accept it. Otherwise, we ask to sender side to resend the file. Then end flag. So same flag patterns up like in the starting or beginning sections. It is appear or which indicates that end of the frame should be acceptable. So a sequence number like y 1 bit. So only one frame is transit at a time. So which means stop and wait. So only needed to distinguish the current versus read transmitted. So 0 and 1 suffice the authenticating bit protocols. So receiver discard the duplicate if a sequence number mismatch or matched last. Then error reduction with cycle redundancy check methods. Sender compute the checksums over the frame data. So as we know how to calculate the checksum methods, and checksum is appended before transmissions, and a receiver compute the mismatch means error. At the end of the section, we need to recalculate the same methods to use identify whether the data should be reliable or mismatch anything. And corrupted frame is discarded, and sender retransmit the data frame again. Coming to the protocols detailed operations scenarios, like in the scenario normal transfer, like sender send the frames a sequence of from start from 0, and receivers check no error found. If it is error found, we will give the acknowledgement to the receiver sender side to resend the file, and receiver send the acknowledgement if it is sequence 0, and sender sends next frame for the sequence of 1. Then scenario B, like a frame lost. In case of data losses, the sender send the frames as sequence 0. Frame is lost in channel. Sender lim timer experience a timeout. Sender retransmit the frame as a sequence of 0 number. Within the particular time, it should be reached to the receiver side. If the receiver experiences a timeout or time delay, a sender need to send again resubmit the frame. And then the third scenario, C, acknowledgement lost. In case of a sender send the frames 0, receiver is received okay, receiver send acknowledgement, but it's lost, which means the file in case of lost the data, sender timeout retransmit frame 0 again to send the frame of 0, then receiver duplicate detected sequence 0 again discarded and asked to resend the file. So these are the method of transferring the method. Coming to the efficiency and the performance analysis. So how we can identify the efficiency and performance analysis of the methods which we use for the data transmissions. So channel utilization formula like efficiency which equals to TT, which means frame transmit time over the frame transmit time addition of propagation delay with track 0. So we simply like a TT over the TT plus TP times up to plus track take. So the scenario like short cable method and satellite link and fiber LAN and cross country WAN. So these are the communication methods to transmit the data or transmit the frame one to another. While using a short cable method, in case of frame transmit time like 100 microseconds, propagation delay like zero point 0.1 microseconds. The efficiency should be 99.8 percentage. Coming to the satellite link, it's like a 36,000 kilometers, like 1 milliseconds of frame transmission time, and propagation delay like 240 milliseconds, and efficiency would be 0.2 percentage. Coming to the fiber LAN method, so this is one of the data transmission via using a fiber LAN. So transmission frames like 1 milliseconds time, and propagation delay like 0.01 milliseconds, and the efficiency should be the approximately more or less 98 percentage. And cross country WAN methods like 5 milliseconds time, and propagation delay like 25 milliseconds, the efficiency should be 9 percentage. So this inefficiency motivated slightly Windows protocols. Go back to N and select repeated method. Repetitive. Why often inefficiency like a sender side ideal waiting for the acknowledgement, and a high propagation delay due to long which equal to long ideals, and only one frame is or only one frame in transmit at once, then wastes bandwidth on logic and faster links. So coming to the comparison of simplex methods, simplex protocols, we already discussed a unidirectional or yeah, unidirection or unique protocols like one-way communication methods and stop and wait method and noisy channel methods. So in that methods, we error control method of first protocols like non, it is not possible for the error control because it is a one-way communication. There is no acknowledgement received from the receiver side, and here also error control method used for the stop and wait method, but it's possible, but it's slightly not efficient when compared to the third methods of a noisy channel methods. So in the noisy channel methods, in case of frame damage or data losses, we will use for this for cycle redundancy check method or some checksum methods to retransmit the data again to receive from the sender side. And flow control in the flow control of simplex protocols, in the first method is not applicable because it's a continuous flow method, there is no any restriction to stop the flow. And here it's possible in the stop and wait method because from the receiver side, receiver send the acknowledgement. Based on the acknowledgement we can maintain the flow as well. And third method also, noisy channel methods is possible based on the acknowledgement and channel type. So this is a error-free method only we can use for this kind of communication. In case there is no error appear while transmitting data, that environment we can use channel. That kind of channel type we can use for these protocols. And this is also error-free methods and noisy real. Acknowledgement record is no for the unidirection or unrestricted. And second method for this yes, which means acknowledgement record for the execute the next frame transmission. And the third one also is mandatory. Sequence number not needed, and here also not needed, and 1 minus bit 0 or the 1. And here's a time or timeout. It's not applicable for this unrestricted methods protocols. And here also not restricted for the time or not dependent on the time. But in the third case, depend on the time. If it is time delay, we need to consider for the data retransmissions. And coming to the efficiency, high in the case of ideal transmission and medium efficiency can achieved, and lower and reliable efficiency can be achieved. Real world uses like not much and non-applicable not and yes ARQ basis. So coming to the real world relevance and applications like point-to-point protocols over serials DSL, and implement the stop and wait style acknowledgement for the link setup and transfer. And in HDLC protocols, high level data link protocols, a direct descriptions of these protocols uses the acknowledgement and timer and sequence number for the WAN link. And coming to the Wi-Fi, every unique frame is acknowledged at the data link layer. Timeout plus retransmitter mechanism mirrors protocols 3 exactly. We will use for this one. Coming to the Bluetooth, basic data channel uses stop and wait ARQ method and 1 bit sequence number prevent the duplicate packet acceptance. And TCP, transmission control protocols layer. So it's the reliability and acknowledgement, timeout methods, and retransmit and sequence numbers are also consider for these methods. Is conceptually identical in the protocols 3 selected to transport layers. Satellite and space like CCSDS, deep space protocols extend these ARQ principles to handle extreme propagations delays of hundreds of seconds. In that summary, in the protocols of unrestricted protocols, like a perfect world for no error, no flow issues, one-way data, inefficient buffer, sorry, infinity buffer, and a purely theoretical baselines method we can use for this one. And coming to the protocols to stop and wait methods, our noiseless method, added flow controls via acknowledgement, send us wait before send frames, prevent buffer overflow of on error-free channels. The third of adds cycle redundancy error reduction methods or checksum methods or timer or retransmissions and one bit sequence order of execution numbers. These IS and ARQ protocols. So follow the efficiency trade-off like T or the TT or the TT addition of TP times up to the stack. Simple but inefficient on high bandwidth long distance link motivates sliding windows. Foundation for the advantages protocols like a concept background concept uh, bedrock of GBM selective repetitive and HDLC and PPP methods and TCP transmission control protocols and yeah, that's it. Uh, that's it. Thank you very much.